be allowed to see this, which I'm not showing it to you right now. Sorry about that. That's better. Okay, so parallel lines and transversals. How do we know these are parallel? These arrows right there. Tell me those are parallel. And then we're looking for angle BKM. So that's this angle right here that we want to find. The purple angle. And we have our checkerboard. You guys remember the checkerboard? Those angles are all the same. These angles are all the same. Okay, and then these two will add up to 180. This one's 32. So we have 148 for M. This purple, well, this purple is the same as this purple, so it's 148 degrees. Not too bad. Okay. And I don't think this will happen, but remember, if you're typing these in, you have to put it over here on this side, or you have to put it over here on this side. You can't just like randomly type it in the middle. Then we have number 2. Again, parallel lines as indicated here and here. We're looking for M, K, J, so we're looking for this angle right there. And we know that this angle is the same as these 3. And that those angles are the same, or sorry, and these angles are the same as each other. To me, this is a little confusing. This 98 is kind of in the middle. That goes to this line, since that angle has a line on it, so you know that they're talking about that angle over there is 98. So we need to figure out what is the red. So this green is 58, so I can find the red by subtracting from 180. So it's 122. Good. Triangle classification will be on the final, and no problems with that one. Any questions on the first page? Does it? Interesting. Another triangle classification, so this one's another one that would be on the final. Any questions on that one? This we did term A, you might remember, and it's not something that would be on the final, but it would be on the end of course, so we're going to review it. So we have some line, right, with a midpoint, and this point is 25, -5, and the midpoint here is 18, -1, and I don't know this point over here. That's kind of the scenario we have. And I showed you guys 2 ways to do this back in the day. Okay. If you remember the midpoint formula, and we did a version where we plugged all of the information we had in. And then this expression gives us 18, and this expression gives us -1, And so we set those equal to 18 and -1 and solved them. Do you guys vaguely remember that? Okay. So that's method 1. You'd solve those. Or you could do method 2, which is you take the midpoint, multiply it by 2, and then you subtract the endpoint. Do you remember doing that too? So I'm going to do that one. And distributing the 2 gives me 36 and -2. And distributing the minus gives me -25 and +5. 36 minus 25 is 11, -2 plus 5 is 3, and so this is my end point. And the question was, what was the value of the x coordinate? And so 11. And if we had solved each of these equations, we'd get the same answer. So we have the distance formula. Oops, minus so x1, y1, x2, y2. So -16 squared plus 28 squared. Questions about that one? Alright, so we have the centroid, and I made this little reviewy thingy. Oops, sorry, no, this little reviewy thing. The medians go from a vertex to a midpoint, and those give us the centroid. The altitude goes from a vertex to the other side, 90 degrees. Those connect to the orthocenter. The perpendicular bisects go from the midpoint at 90 degrees. They may or may not hit a vertex. Those give us the circumcenter. And then the angle bisector cuts the angle in half. We don't know anything at all about these lengths. And those connect to the incenter. Okay. So, from that, if we know that this is a centroid, O is a centroid, that tells me that EB is a median. And that tells me that these lengths are the same. Okay. The fact that this is a centroid also tells me that this length is half of that length. That's all the information I have. So going from there, sorry, how's that better? So going from here, I have BO and OE, those are not congruent, so that's not true. DF and AE, I have no idea. CD and BE, no. AE and EC, that's what I have. AE and EC are congruent because E is a midpoint. This, which is based off of what we had. So the medians gave us the centroid, the perpendicular bisectors gave us the orthocenter, sorry, the altitudes gave us the orthocenter, the perpendicular bisectors gave us the circumcenter, and the angle bisectors gave us the incenter. With the centroid, we have that this length is half of that length, or this length is twice that length. Okay, and the whole thing is 3 times x. The orthocenter gives us absolutely nothing. It's just the name of the point. We don't do anything with it. If you have a circumcenter, you're bisecting the sides, and so the point to the corners are the same length. So it's like the opposite. And then with the incenter, you're bisecting the corners, so the points to the sides are the same length. Okay, so that's this. Circumcenter goes with the perpendicular bisectors. That's where the perpendicular bisectors intersect. So we just look for the question that's talking about the perpendicular bisector. So B. Oh, also, sorry, 8 and 7 would both be things that would be on the final. So 7 and 8, because that's the stuff we just covered. Those will be on the final. So number 9. 9 is another final exam type of question. And this is the triangle inequality theorem. Which tells me that the sum of 2 sides has to be greater than the other side. Remember that? Like any 2 sides have to be bigger than the third. And so this is the one where I add and subtract. So if I add, if I subtract, I get 7.5. This 7.5 is the smallest length that the third side can be, and well, it has to be greater than this, and 31.5 is the largest that it could be. So anything that's a possible length has to fall in between 7.5 and 31.5. So we just look at these. Those are all okay, but A is only 7, which is smaller than the smallest, so it won't work. Hinge theorem. And remember what the hinge theorem told us is that the wider you open the angle, the wider the third side of the triangle will be, basically. So this is the road side or the street, and this is the angle. And she wants a long property line along the street. So she wants this line to be the longest as possible. These are my different angles. So which angle is going to give me the longest third side? That's going to be the largest angle. So 103 degrees is going to be the largest angle. Which will be the longest side, so quad D. Okay, for number 11, we've got that let's see, we've got DC and AB are the same. And then this angle is the same as that angle. And then this side is the same as itself. And these are our triangle congruents. Remember, we can have side, angle, side, angle, side, angle, side, 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 or angle, angle, side. We just can't have angle, side, side. Okay, so right here we have side, angle, side. So these two triangles are going to be congruent, which means that if this line is 160, this line is also 160. Because we've got side, angle, side congruence. Questions on that at all? Okay. This next one, we didn't actually get to this, unfortunately. But it's part of algebra, so it shouldn't be too unfamiliar. We're talking about proportional. Similar means same angles, different lengths. Okay, and they're proportional to each other. So what will happen is if we look at these triangles, okay, 75 to 45, 75 to 45. These two yellow lines will be in proportion to each other because they're the sides between the congruent angles. And then I have 60 and 45 and 60 and 45, so those green lines will be proportional to each other, and then the final length of the triangles will be proportional to each other. Now for the setup, if you always remember to put the small over the big, then you'll always put them in the right order no matter which triangle you or which section you put first. If you put the smaller one over top of the larger one, then you always have them in the right way, because we need to set small over big equal to small over big. If you do small over big equal to big over small, you won't get the right answer. So small on top just kind of makes the most sense logically. So we are going to do the yellow lines into a single fraction together. So 28 over 42. 28, 42. And then we'll do the green lines, question mark, and 33 I'm going to call question mark x. And so I have 28 over 42 is equal to x over 33. Cross multiply. And we get 42x is equal to 924. Divide both sides by 42, and you get 22. So that missing side of the small triangle is going to be 22. Now we had to set up the proportion because I couldn't see the enlarging or shrinking factor between these two. Like 28 doesn't evenly go into 42 or vice versa. Sometimes though you'll get to see that factor and you don't have to do the proportion. Like this example here, 13. 11 times 3 is 33. What times 3 is 9? Does that make sense? So I go from 11 to 33 and multiply by 3. Or if I go backwards, to go from 33 to 11, I divide by 3. So sometimes you can see the shrinking and enlarging proportion. In this proportion, they're proportional to each other by a factor of 3. So if this is 9, this has to be 3. Because 9 divided by 3 is 3. So sometimes you can see it, and sometimes you have to set up the proportion. If we were going to set this proportion up, I would do 11 over 33 is equal to x over 9. Then cross multiply and I'd get 33x is equal to 99 to find x equal to 3. Anytime you chop up a triangle like this, if you do parallel lines, you get proportional sides. Let me just double check something. So you can do this two ways. I can either do 4 over 18 is equal to x over 22. Or I can do 4 over the whole length of this side of the triangle is equal to x over the whole length of this side of the triangle. So like the small triangle over the big triangle. It's easier to go ahead and do 4 over 18, x over 22. So cross multiply. X is equal to 88. Divide by 18. And x is 4.9. Okay, so if we look at this, we've got a name, some characteristic, and another characteristic. And then we're talking about a square and a rectangle. What is the only difference between a square and a rectangle? Yeah, like sides, right? Squares have all like sides, rectangles don't, so that's our missing characteristic. Does that make sense? Okay, for this one, we need to know some characteristics of kites and rectangles and trapezoids. Okay, so kites' diagonals do dissect at right angles. So if you have a kite, the diagonals come through like this and intersect at right angles. So this is a true statement. And there's only supposed to be one, so we've already got it. But just to go through, trapezoids don't have two parallel sides. They only have one, right? Here and here. All shapes are parallelograms if they have 4 sides and 1 pair of parallel sides. Parallelogram has to have 2 pairs of parallel sides. And then parallelograms, if they have 2 pairs of sides the same length, that doesn't. You have to have 2 pairs of sides that are the same length, but they also have to be parallel. So it's not enough to just have 2 pairs of sides that are the same length. They have to be opposite sides that are the same length. Does that make sense? Because in a kite, I have 2 pairs of sides that are the same length, but they're not opposite sides. So it doesn't work with a parallelogram. Opposite sides are the same length. Okay, when comparing a square and a rectangle, there's only one major difference. Squares have 4 equal sides, rectangles don't. No questions on those, right? Okay. Trapezoids and kites. Kites don't have congruent diagonals. Trapezoids have parallel, like one set of parallel sides, but not kites. Neither of them have to have 4 congruent sides. Actually, matter of fact, a kite does not have 4 congruent sides, and a trapezoid can't either. So the only thing they have in common is that they're both quadrilaterals. They both have 4 sides. Oops. So let's look at number 23. Okay, so we've got a square with vertices at -3, 5, 7, 7, and 3, 3. And we want to find that fourth point, which is going to be here somewhere. Oh, sorry. Didn't realize you guys can see. So I have this point, and I want to get some point in this general area here. Because it's a square, which is also a parallelogram, I know that the distance from here to here is going to be the same as the distance from here to here. Because squares have even sides, like opposite sides, that these two lines here would be the same length. So the right triangles would be the same length. So to get from here to here, I go down 2 and over 4. Because this was 7 and this is 5, so that's down 2. And this is 1 and this is -3, so that's 4 spaces there. So if I go down 2 here, I go from 3 to 1. That's my new y. And if I go from back 4, I go from 3 to -1. And that's my new x. So the point where they would make a square is -1, 1. There. You guys couldn't even see any of that, could you? Sorry. Does that make sense though? 24, we have another graphy bit. Let me just zoom out one. Okay, A, B, C, D, I have -8, +8. A, B, C, and D. Okay, so there's that one. And based off of the spacing, I know that those are all sides 4. PQRS has 10, 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Q is, oh wait, that's probably supposed to be -10, 10. Darn it, -10, 10. Q is -2, 10. R is -2, 2. And S is -10, 2. So we have another square. And the difference between these sizes is 8. Okay, so looking at my answer choices, they're both squares. Because they're both squares, they're similar. This one is enlarged by a factor of 2 to get to that one. Does that make sense? Good, bad, indifferent? Okay. Convex or concave? Do you guys remember those? It's concave, right? Because it bends in. Then we just got to count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's concave hendecagon. Okay, Athena says this is convex and irregular. Well, it's definitely irregular it's not convex because it goes in here. And it's got 1, 2, 3, 4, 5, 6, 7, 8 sides, so it is an octagon. So octagon, yes, convex, no. So she's, oops, she's not correct. Good. Convex is where you're all, like there's no bends in it. So your regular squares, your regular triangles, parallelograms, these are all convex. Concave bends in, like it caves in. So this would be concave. Anything with like a in part. Does that make sense? Okay. So as long as all the vertices are pointing out, you're good. You're concave. Sorry, convex. Concave caves in, convex doesn't. So as long as you're pointing out, you're convex. If you cave in or you point in, you're concave. All right, a regular decagon, 10 sides, is shown with isosceles triangles drawn within. Isosceles. Okay, what is one way that you could find the measure of the exterior angles of the figure? Okay, hold on. Add all of the angles in the triangle together to get 180. Well, that doesn't really help us with the exterior. Add the base angles of the isosceles triangle together to determine the measure of the exterior angle. Not really. Find the measure of the non-base angle of the isosceles triangle. That's not true either. Okay, subtract the base angles of the triangles from the exterior interior angle measure. Okay, hold on. Remember that? Okay. This is a decagon, so that means each one of these inside here is 36 degrees. And because it's isosceles, that means these two are the same as each other. So I think, see, I don't think these are written very clearly, because what we would want to do is we would want to take that 36, we want to take 180 and we want to subtract 36 from it. And that gives me 144, which we would divide by 2, and that would tell me that this angle is 72, right? And that would make this angle 72, which make this angle 72, and that angle 72. Oh, okay, I see it. I could subtract the base angles because these two are the same, and that adds 180. So that makes this 36. So it is D. It's just written weird. So sometimes you kind of have to try to do the problem to figure out how to do the problem with the way they're saying. Does that make sense? Okay, we have a barn. And we have 1, 2, 3, 4, 5, 6 sides. And we're trying to find this angle measure right here. And a 6-sided figure to, I don't know if you guys remember total angle measure. Where n is the number of sides, so this would be 180 times 6 minus 2, so that would be 180 times 4. Would give me all of the angle measure for this 6-sided figure. Which would be 720 degrees total. can add up all of these to 720. So let's do that. $134 plus 128 is equal to 720. So 10, 15, 20, 30x, 4, 12, 8, plus 134 plus 128 is 270. So far okay? Minus 270. So I get 30x is equal to 450. Divide by 30. And you get x equals 15. And f was 10x minus 4. So that's 10 times 15 minus 4. So that's 146.